So for those of you who joined just now, I have created a handout also for this. So you can access the handout at the link present in the Etherpad. I've added the link there.
What is the handout here?
So on the Etherpad number 3, there's a link. You can use that. So I don't really have access to the blog as such. So some of the changes I did at the last moment, it's mostly there in the handout.
Okay.
So I've added a few variations of the problems in the handout, so you guys can take a look at that.
Hello.
Hi, Pamela. Are you able to hear me?
I can hear you.
Okay. Yeah, so I was just saying that there's a handout for this session. So you guys can access the handout at the Etherpad link. There's a link there inside Etherpad. You can use that.
Is it the one that Vivek let us know before?
No, so I just created this, and it's there in the third point of the meetup information on the Etherpad. Yeah, so the Etherpad is same, but the link to the handout is something that I created.
Okay, because I saw email a few days ago. Okay, you can access the handout at. Okay, I'm looking. I just got a big fat error.
Oh, really?
Yeah. So, and then now it says sign up to cloud.app.
Okay. Let me see if I can use some other.
What I did is there was one on the meetup session in the comments that Vivek posted, and I was wondering if you're working off of that.
So yeah, so mostly the questions are same, but this handout has some solutions and some variations. So it's not really necessary. I can update later on too. I mean, we can just go off of the blog right now. It's not really. I'm just letting you know, if you wanna look at the solutions later on, maybe we can use that.
Well, I'd like to look at the solutions, but I can't get to them. And I got to the questions just fine, but.
Right. So let me fix that link and.
It says 4th August handout.pdf, download. Okay, so download.
Okay, you got it?
Let me see. I have pretty poor internet, so that's part of the problem.
Oh, I see.
And it's still downloading.
Okay, I think we can start.
Yeah, here we go.
Yeah, so the first question is the twosome problem. So anyone want to take a stab at it?
I have a solution to the moderate version.
Okay, so easy solution is probably anyone want to just quickly go over the easy solution?
Yes, for every number you have to check if there is an equivalent sum. If you have two numbers ai aj, you check for every j, right? So for every n numbers you'll check for the other other n numbers are n minus 1 numbers are actually
Yes, right.
candidates.
Yeah,
So
basically,
it's a naive way of going about it.
correct. So that's the easiest way. Yeah. So you're saying someone has a solution for the easy to moderate. That's O of n log n.
Right.
Well, I had order of n, but it uses more space.
Yeah, that's fine. Yeah, that's the moderate solution. Yes.
I have the order of n, but can use extra space.
Yes.
And I can describe the solution, and basically, it is you're given t, and then you look at the first item in the array, and you subtract it from t to generate a difference.
Okay.
So I created a hash map to keep track of all of my possible differences. And so so basically, with the difference, I created an integer, and then I went into my hash map and saw, okay, my key is the difference, and the value would be the index of the item that would correspond. Do you understand what I mean?
Value of the item that would correspond to that. Okay.
So let's say t was 10, and so t was 10, and a of 0, we're starting off in the array, is 5. Then the difference would be 5, correct?
Correct. Yes.
So what I would do is I would generate my difference.
Okay. So
and it can be a negative number.
Right.
And then I would generate my difference, and then I would look it up in my hash map. If the difference was there, then I've already seen an index that has the pair that goes with that.
Correct.
Otherwise, I create an integer value using the index, and I save it off in my hash map.
Yes, that's correct actually. Yeah.
Yeah, so, and then and so basically, if you've got it, then you have the one of the pair is the value of the index, and the other one is your I, and you've got your two indices.
Right.
So that's just, and as I said, I'm sketching that out, but hopefully you understand all that.
Yeah, that's actually correct. That's definitely the solution, like O of n solution. Yes.
Yeah, that's O of n with extra space. Now, what I'm really curious about is the hard one.
No, I think. So, what do you want to do? You want to go to login? That's not possible, I guess. So, any idea on what is the n log n solution?
So, the n log n solution, I suppose, would be to sort the array.
Right.
And once you sort the array, use 2 pointers, one in the first index, one in the last. But by using this, if this has to be a no extra space solution, then that means we'll be losing the given array.
You will be what?
We'll be losing the order of the original element. So if that is allowed, we can do it in constant space. If that is not allowed, then we would need to copy the given array into a new one.
How would you do it by rearranging the array?
So once we sort,
by the way, there is a way to do it without rearranging it. So, yeah, go ahead.
Okay, so I mean, without rearranging, I don't have a solution for that.
Yeah,
But
that's
by
fine. That's fine. Yeah, you can just tell us what solution you have in your mind.
yeah, so use something like a heap sort or any kind of sort. So that will take n log
Okay.
n time.
Okay.
And once that is done, you use 2 pointers, one at the first element and one at the last element of the array. And I'm sorry, is
Okay.
someone saying anything?
No. Who is speaking? Actually, the solution. Who is speaking?
This is Vaibhav. I joined by call actually.
Oh, okay. Fine.
Okay.
Go
Yeah.
ahead.
So, like I said, so
I don't know why, but the voice is echoing.
Yeah. So yeah, even I have that problem.
Yeah, I'm sorry about
I
that.
guess. Yeah, I'll mute a few people. Okay. Is
Yeah.
it
So
good
what I
now?
was saying is,
Yeah.
yeah. So what I was saying is, we use 2 pointers after sorting. So one in the first element, one at the last, and then we suppose look at the first element,
Right.
and suppose the sum of the 2 elements is greater than the required sum, then we decrement the last pointer. If it is greater than the
Correct.
sum of the 2 elements, then we increment the first pointer, and
Right.
at some point we will reach the sum, which is where we will have both the indices.
Right. Oh, okay. So by rearranging the array, you meant sorting the array. Yeah, that is allowed. Yes. Sure. Yeah,
Yeah.
that's correct. Actually, that's the solution. That's O of n solution. Yes.
Yeah, and in that case, we will need an extra space to store the indices, right?
So that's just so usually when you are computing space complexity, you see if the space is growing as a function of your input size. So if your input size is n, if you are storing 2 indices, it's the same whatever you do. So if if your n is 10 or 1 million, your index variables will just be 2 variables.
Yeah.
So yeah, it's not growing. So basically, you can ignore that it's a constant.
Hi, I had a question. For the n log n solution that's given in the handout, is it r plus plus or r minus minus on one of the lines?
Oh, is it written as r plus plus?
Yeah.
Oh yeah. So that's a that's a typo. I
That's
guess.
a typo. Okay,
Yeah,
got it. Yeah.
it's r minus.
Yeah, just making sure. It was pretty obvious. Just making sure.
Right. Yeah. So does anyone know what we can do for threesome? Like basically, there'll be what's the numbers which add up to a given number instead of 3.
So just a question. What was that handout about?
So in the either pad, I've just added a link to a handout. It's just basically the same things but with some solutions.
Oh, okay.
Yeah. So mostly, most of the questions have some kind of code there. It may not be bulletproof. I've not tested it, but mostly it gives you an idea of what the solution is.
Okay. Thank you.
Yeah. So any ideas on threesome problem? You can just take a stab at it. So what's the worst you can do with a threesome problem?
Is it instead of having a target?
Yeah.
I think one of the basic approach that we can take is just start, scanning the array from beginning and keep adding to some variable, and just keep scanning the array until you reach the end of the array.
Yeah.
So yeah, that's going to like worst case. I mean, it's going to be O of n square. So just at the first index of the element, just pick that, then start from the second
So
index.
you have to consider almost all possible triplets.
Yeah.
Uh, so how is that? Okay, do you really think you can do it in O of n square using that brute force approach?
No.
Actually, I think you are right. It's going to be n cube.
I have
Yeah,
hello.
correct. That's O of n cube.
Right. Didn't think about it.
So the worst you can do is O of n cube.
Right. Agree.
Can we somehow make it O of n square?
There is one approach. We sort the array and pick two elements, and then for the third, uh, subtract the two elements from the total sum and apply the Twosome problem.
Okay, so you'll first sort the array and then you will do what? Go ahead. Actually, don't feel embarrassed or anything. You just
I had n square log n solution.
You have resolution here.
okay.
You have resolution here.
So
Okay.
we can sort the array, that is n log n. And
Okay.
after that, like for Twosome we used 2 pointers. So we used the same 2 pointers, one at the first element, one at the last.
Correct.
And we can do a binary search, and the sum of those two elements minus or rather the total sum minus the sum of those two elements will be the third element which we need.
Correct.
So yeah, so we can do a binary search on the remaining the portion of the array which is in between the two indices. So if we don't find the element, then I don't know,
I think we can use the same approach that you are mentioning. If we can do binary search and use middle element and first element, then take sum of it. If sum is bigger than the actual sum, like the main sum that we are trying to find out, then if it's bigger, then we know a third element lies in the left portion of the binary search. So we have to search in that section, which is going to work.
So
log n.
binary search, what is the key actually? So why would you use a binary search?
no, I mean we would sort the array, right? So
Right. Yeah. So you've sorted the array, but you are going to find what the difference from the t minus say this and the last one and then the other one, right?
correct. Yeah.
Okay.
So if we find it, we stop. If we don't find it, I'm not sure exactly whether to increment the first element or to decrement the last element. So I actually stopped speaking.
I think if last element pointer at the last element is greater than the actual sum, then we can't do anything about it. So we need to move forward. We need to kind of change the pointer.
I think
No,
that
but-
solution might work. Whatever
No,
you are
actually,
saying.
but that actually won't work if if the total sum is actually less than sum of the two given sum of the two indices we picked. Suppose the first element plus the last element is say something like 13, and the total sum you need is 25. So
Then we don't have right array, like we'll return -1 or something.
no, how come you could possibly
Okay.
if total sum is say 20,
Oh, I
then
get
you
it.
could have, yeah. So we won't know which way to move. So I'm not sure if that is a possible solution.
I have one approach. So you sort the elements and pick the last element as a one member in the threesome, and find the two elements using Twosome with the total value of t minus last element.
Right. So if you do
And then
that
if
for
you
every element,
don't find it, then start with n minus 1 and then pick that one as the first element and then
correct.
find the second element.
Yeah, so that's O of n square. I guess that is the best you can do. But this is actually a very interesting approach. I had not thought of this. Doing a binary search on sorted array with two elements. But I don't know if it will exercise all of the combinations of the triplet. But it seems like what the solution to try.
Yeah, I think an extension of what was just now mentioned as the solution, like that will work. Even if we add binary search in there, we can make it a little more efficient, though it will remain n square log n.
Yeah, so it's kind of that's what. So even if you do a binary search, so that's probably a log n search. But here what he's doing is for every element he's doing the twosome on the remaining array. So the twosome you could complete in O of n, and then for each of the n elements he's doing that. So it's n square.
No, but you are doing all this on a sorted array.
I don't think you can do binary search because you have to exercise all the possible combinations for the two elements.
No,
So
but
even
But why cannot that be done if we can have the two elements using like 2 pointers on the sorted array, and then we search for the third element? If it is not there, then that's not a possible solution. We move our pointer.
What is that? Can you repeat?
I mean, I just didn't get why the binary search solution.
Yeah. So binary search, I don't think. Yeah, it's not possible because it won't go through all the combinations.
Like, because what will happen is that the first two elements that you are picking, they will be n square.
Yeah.
Right. So you are not doing better than n square. But if you pick just one element and then do some problem on the remaining array, it is n square.
Yeah.
Okay.
So if by picking two elements and doing binary search, you are basically making n square plus whatever time, the log n time for searching the third element.
No, even if you can't. So even if you want to do binary search, it will not have all the permutation of two elements that you require. You need to search through that whole thing, right?
Yeah, that's what like for the first two elements you have to do n square, and then it will be additional cost of, if you just want to find the third element, it will be cost of log n in addition to n square. So it is worse than n square.
But why do you have to do n square for two elements to find two elements? So like this solution sounds perfect. So you fix one element and then it is a two-sum problem. So now the two-sum problem we were able to solve,
using ON.
Using n log n and n. Yeah. So.
Yeah.
But
that's what I'm saying. There is no point in picking up first two elements and then finding the third. It is better you find one element and then you convert it into two-sum problem.
Yeah, that makes a lot of sense. Yeah.
Right.
Yeah.
So anyone want to try a four-sum problem?
Just had a question for the two-sum problem.
Okay.
So if we are using 2 pointers, one at the starting and one at the end by sorting, it is order of n log n, right? Because we sort and then we...
Yes.
Yeah. So what was the ON solution? Maybe I just missed that.
I think it's a hash.
You have to use a hash table, and then you can subtract the t, whatever the sum, and minus the current element and add it to the hash table. So when you go through the things, if you find the element, the complementary element, then you basically say that okay, these are the two things.
Okay, got it. Thank you.
Yeah.
Arun, before you move on, I had a question about this meeting actually. So can we, are you sharing anything? Can we see this online or is it just telephonic?
So no, it's actually happening online. Are you guys able to see my screen?
Yeah.
Okay, yeah. So you can log into the wall, the freeconferencecall.com/wall/sd skills, I guess.
That's
The
/join/sd skills, and then you can
Right.
call using your system.
Yeah.
Speaker.
So
Can you please ping that link into the chat?
Yeah, sure. I can do that.
Okay, thank you.
But I mean, here it's asking me to log in. There is no place to register actually.
So
It doesn't need registration. You can just go to that link given in the meetup, and then it will allow you to log in without registration.
Yeah.
join the wall instead of yeah. So yeah, anyone want to take a stab at Twosome problem? So you have four. What four elements would add up to a given number? So the naive solution would be O of n power 4, right?
Yeah.
You
So
basically
we
go
can.
through all the four quintuples, and then you find out which one adds up to the sum. But is there any better solution? Remember, you can use extra space.
I mean, the cubic will be very obvious, right? You can just choose one index and then apply the threesome algorithm on the rest of the array.
Yeah.
Right.
So yeah, you could do that.
Cubic will be very obvious.
Yeah. But there's you can do a little better than that.
One approach would be to take all the sums in n square and sort them,
Right.
and pick a number, pick a sum, and look for the t minus that sum in the list, like a Twosome problem.
Yeah. So basically, once you have n square, so basically you take the pairs of numbers. So that will be n square, and you make it an array. So you have a big array, which is and then you sort it. So it's n log n plus n square, and then after sorting you can apply the Twosome thing, basically.
Twosome on the rest of the array.
Yeah, Twosome on the expanded array.
Okay.
So I have one question. So how do you make sure that does not come from less than 4 distinct elements? Say the two different sums can be, say, p plus q and q plus r.
Okay.
So there is one element contributing to each of those two sums. So then there is one duplicate. So how do you ensure that the two different sums comes from 4 distinct elements?
So there will be no overlap of elements when you permute the n square, the pairs.
Okay.
I don't think there is.
Oh, I see. Okay.
Because it's commutative, right? So you can neglect the pairs which are like. So you can just basically arrange the array in such a way that you don't really encounter that.
I see.
No, like consider we want a sum of n, and we have in the lists we have numbers like 1, 2, 3, and 4. So 3 plus 2 and 4 plus 1. Like ideally for Twosome problem, 1, 2, 3, 4 would be a set which we are interested in, but we don't want 3, 2, 3, 2 to be considered. Like 3 and 2 to be considered twice.
Yeah, exactly. So that's what he was saying, that what happens if there is repetition.
Yeah, like I'm just giving an example of his concern. So how do we deal with that?
So, okay.
He's got a point.
Yeah, definitely. Anyone can think of any solutions? Let me see.
Also, I had another concern, like how are we backtracking the sum? Like, okay, like multiple tuples can be of the same, can lead to the same sum, right? So probably, probably we could once we find, probably when we find that okay, combination of these two sums gives us the final set, maybe we could check if whether they are distinct or not.
So a solution would be like, in the 2D array structure, let's say you picked up I and j as the first two indices, then you'll ignore the ith row and the jth column for, you'll just take that part out, like, and find the two elements which which give you the final sum in the rest of the matrix, and just ignore just ignore those two, that row and that column.
Okay. So no, you can still have a single dimensional array, but when you encounter the sum to be equal to 10, you can check if the tuples are same, basically 3, 2, 2, 3. So I guess that would not be, acceptable, basically. So you could write it in such a way that you just only accept non-distinct tuples. So, I guess that's the easiest
I think
solution.
we store the tuple information in hash table, hash map.
Yeah, you have to store it together. That's the
Yeah, that would work too.
Okay. Moving on. So, any one of you want to try the next one? Find duplicate. So there, it's all positive integers. There's an array of size n plus 1, and every number is between 1 and n. So that means at least one number extra has to be there. But the constraint is that there is more than one number. The duplicate is not necessarily just one more. So there can be multiple numbers. There can be 2, 2, 2, 3, 3, 3, and so on.
But you only need to find one.
What's that?
You only need to find one duplicate.
Yes. Yeah, you only need to find one.
So there can be more than one also, right?
There can be more than one, yes.
But if the array size is n plus 1, and every number is between 1 and n, then it need not have a duplicate, right?
Why not?
It is actually the other. Yeah.
Because there are n numbers.
No, it was actually n plus 1 size, but we are having 1 to n. So definitely there will be a duplicate.
The number of elements is n plus 1, and each number is between 1 and n. So there has to be at least one number which is which is repeated, right? Because every number is between this interval. Once you have exhausted the n numbers, you have to repeat one number.
Can you hear me? Yeah, it makes sense.
Yeah. Who is that?
This is Jaime.
Hi.
So it looks like the easy one would be to start at I, look for something like it by going from I to n, and then just increment I as you go along, and that would be n squared.
Correct.
Right? So the moderate...
you go through each of the elements and compare each of the other elements, and then you know which is the duplicate one. Yeah, that's the easy one, O of n squared.
Yeah. I think the moderate might be using a hashtag and see if you have a collision.
Correct. Yes.
Right.
Hash that, yeah.
Like a simple one-to-one hash, right?
Yeah.
The other thing that we can do is we can go through the array like from I to n, so from 1 to n, and then whatever number is at the ith location, we try to put it, like if we can change the array, we try to put it at for example, if I have say 1 to 10, and the first element is 5, I just go and then I swap it with the, or not swap it, but try to put it at the location 5. And then in this way, if I find more than one element, like if I see that the index is already occupied with another number which is same, then that's duplicate.
That's correct. That is the O of n solution. And since you are not using any other array or hash, it's O of one space. So yeah, that is the moderate to hard solution. So did everybody else get that?
But it says the array is immutable, right? You cannot modify or rearrange it.
Yeah, so that actually I should have changed that. That's yeah, sorry about that. I should have mentioned that. In fact, in handout I've changed, but yeah, I didn't have access to the blog. So
I had an alternate moderate solution. So
yes,
it'll do a little better than ON.
Okay.
Like if you use a hash table, it is like a space for n elements, right? So if you use a bit array which allows only 0 or 1, so we can the size of the bit array we can have is of size n, and we just traverse the array, the given array, and we update whatever element we find into the we mark it as we mark the zeros as 1. So the moment we see a collision, that's it, we stop there. So that would be, I suppose, that's not ON space, but ON bit space.
So the thing is, maybe that particular data structure is still efficient in say whatever computer that we are using, but theoretically the number of bits grows with the number of elements that you give in. So if you give in n elements, you will need n bits. So that is what we are looking for. So maybe in hash table it takes n integers or whatever n things. So basically you're giving n things and you require n more things to do this. So still it's O of n.
Okay.
If you will use a bit, then you will have like n divided by 8 in the worst case scenario, right?
Yeah, that I actually thought that was the case.
Yeah.
What is that?
Like if you are
using the expression that, like for instance, if I'm doing that solution in Java, I thought my space would be O of n by 32.
Right, but constants you can ignore, right? Usually in big O notations you ignore the constants. So if you are getting a O of n by log n or n square, maybe that will be something interesting. Any questions?
The other, like just to talk about the approach that about bit, it will be even more complex if you have very large numbers, right? To set the nth bit.
Yeah. So those are all implementation specific details. So we are just talking from an algorithmic perspective here. So yeah. So yeah, moving on. If there are no more questions, we'll just move to the third one.
Sorry. The moderate to hard, was it match the number to the index?
Yes.
Well, how do you
do that? It's the one published in your PDF, right?
Yeah, that's correct.
Okay.
So how do you do that if you have like the first number is 1, and then your second number is 1,000,000, and the second number is 1,000,000,000?
Your first number is 1, and then?
Right. Like, wouldn't you be creating way too much, like an array that's way too large?
If you look at the conditions of the problem, it says every number is between 1 and n.
Yeah.
So you have an array of integers of n size n plus 1, and every number is between 1 and n. So he excludes that condition specifically.
Oh, yeah, you're right.
Yeah, so it will never
The
cross.
interesting problem would be in this scenario is what if the array cannot fit into your memory? If you have such a large array that it doesn't fit into memory, how do we solve that?
I guess then the question would be wrong.
You still have n numbers and you need to find duplicates, right?
Right.
No, but the input is an array itself, right? So if the array itself is too large, then
So
it's not your
basically
fault.
you can use the same principle. Maybe you need to access it from the file system, but if you have them stored as a hash in the file system or whatever, wherever you're doing it, you can still do it. But the fundamental algorithmic approach would be the same.
Oh, so you have some specific size files and then you search into nth file. Okay.
Right. Yeah. So, yeah. So,
could you summarize this once again? I'm not very clear intuitively why the index will match.
Right. So if you see, all the elements inside the array are from 1 to n, and the whole array is as big as n plus 1. So you could use the elements inside to index the array that we have. So basically, what you do is you index you just go through the array once, and whatever element you find, go to that index and then swap the element that you have here and there. So at any point of time, if you find that you have you already have an element at that particular location which is the same as what you are testing against, then it means that you've already encountered that. And then so the thing is, you have a duplicate right now, so you can just return from there. Is that clear? Or
I had a question. For the swapping method that we talked about, do we also need to have a condition like if I not equals ai or something? Because otherwise, what if the array is like 1, 2, 3, 4? Because in that case, the element exists at each of those locations.
Yeah, so but the array is as big as 5 if the elements are 1, 2, 3, 4. So the fifth element will have some repeated number, let's say 2 or something like that.
But in the approach which was mentioned, the ON approach, the moderate hard one, so there you are actually losing the given array, right?
Yes. Yeah, because it said on the sheet that it assumed the array was mutable.
Yes, that's I couldn't remove it from the blog. I'm sorry about that. That constraint doesn't hold. So that's the first clarification. So that constraint doesn't hold. I mean,
you could instead of actually swapping the elements, going index by index and swapping the elements, instead of that you can just negate the element at that index, right?
Yeah, that is also another approach. Yes.
So that way, I think you might make some elements negative, but at least you can iterate over the array again and make the array, as it was.
Exactly. Yes, I agree. So since everything is a positive number, you can expect that there will be no negative numbers. So when you negate a number, and if there's a duplicate and you go into the same index and you see a negative number, that means you've already visited once. So you can then conclude that that's the duplicate. So let's move on to the next one. The rotated sorted array. This is a very standard question in the interviews usually.
Maybe I'm not understanding the question correctly, but wouldn't the smallest element in the array always be n divided by 2 plus 1?
I can answer that. So not always, because the rotation can be any arbitrary amount from 1 to n. So
that's what I thought.
If the length of the array is n, so say n is say 100, so you can rotate it by say 15 or 20. It doesn't have to be 50 always.
Oh, I see. So basically what you have to do is
Yes, yes, a sorted array rotated by an arbitrary amount, and you don't know how much that is, and then you have to solve this questions.
I think one of the easy approach of and is just to start from the beginning of the array and just keep going. So since it's been rotated, so it should be either increasing or decreasing. So we can, like, once we start scanning from the beginning, we will see if we are seeing
you just go through and you can find the mean.
Exactly.
That's correct. Yeah.
So
that
wherever like pattern is changing, if it's changing from increasing to decreasing, that means we encountered that point where.
No, actually, you don't even need to do that. You can just maintain a variable and check if basically the same min and max check. You can just go through once and you can find the max or min.
Right. That's true.
Yeah. So that's the easy O of n solution.
Log n is easy as well. Like it's sort of a binary search.
Right.
So you pick up the first element and the last element and you compare.
Okay.
Whichever one is the smallest, and then you take the half of the array, and then you do the same thing. Whichever is the smallest, you again keep on reducing the array in half towards the smaller element.
Correct.
And then once you will reach an element which is now smaller but at the other side.
Yeah,
and then
I think you're right.
Just a request. Can we do it on Etherpad because I'm a little confused with this?
Okay. So do you have the handout actually?
Yeah.
Okay. So I mean I assume that everyone has the handout. So you can go to page 3. There you have the solution. So basically, first few things you just do a sanity check on the input and stuff. So if the number at the left is lesser than the right, that means it's not rotated, right?
Right.
So the minimum element would be the leftmost one. So you just return that. And if that's not the case, so the pivot is somewhere in between. So if there are only 2 elements, it is then right minus left is 1. So you can easily say, so there are only 2 elements and the left is not lesser than the right. So that means that is the pivot point. So the rightmost element is the number which is the minimum, right?
Yeah.
Yeah. So that is one thing, and then you go to the midpoint, and then if the midpoint is still greater than right, so your pivot is probably in the right side of the array.
So it's like doing a binary search over non-sorted array to find the pivot point, and then just return the largest or the smallest or whatever.
Right. So when you return nums of left, that's the minimum that you.
All right.
Whatever.
Let's do this.
Yeah.
Go. Okay, directly. Go straight.
High five.
Okay, sorry about that. That's someone else. Okay. So the next question would be, can you find the largest element in the array?
Yeah, the same approach, but other way around.
Once it looks like once you know the pivot point, you can just smallest is +1, -1, and do a little math.
Correct. So once you know the pivot point, you can just go back an element. So if you are at 0, probably you can just have a special case for falling back to the end of the array. But yeah, once you have the pivot for the min element, the max element is just behind it. So yeah, so how do you find the kth largest element? I guess very similar logic.
Yep. So if we have to find like second largest, so as soon as we find our pivot, we'll just do n minus 2.
Right. So yeah, I think we'll move on to filling water example. I mean the problem. This is actually quite interesting. Um, so yeah, so assume you're given a bar chart. I guess you've read the problem. So anyone want to try?
I have a solution. But if anyone wants to try, I can let him go first.
Yeah. Anyone who's not spoken yet, maybe they can try.
So here is the observation that you at any given cell I, suppose your max L is the length of the highest bar to the left, and max R is the the height of the highest bar to the left, and max R is the height of the highest bar to the right. Now your water level can be minimum of max L and max R. It cannot be more than max R because otherwise the water will overflow to the left. Similarly, it cannot be more than max R, the water will overflow to the right. And the amount of the units of water in that slot is mean of max L max R minus its own height.
Yeah, I would say the logic is correct. Did everyone else get that? Any objections? Any questions?
I didn't get the last thing that he said. Maybe connection problem.
Hello.
Hi, who is that?
Oh, no, Stacey.
No? Okay. Yes. Yeah. Yeah. So, who was that who explained? Avlesh, right?
Yeah, my name is Avik. Yeah.
Avik. Okay. Hi, Avik. So, do you wanna answer?
Oh yes. Okay. So now for every slot we need two more numbers, max L and max R. So max L is the height of the highest bar to its left, and max R is the height of the highest bar to its right. Now see, let's take example of this 1, 2, 3, 4, 5th slot. Now it has a on its left there is a bar of height 2, which is the maximum, and on its right there is a bar of height 3, which is the maximum, the highest bar to its right. So we have these two heights, 2 and 3. The minimum, we have to take the minimum of them, which is 2, and see that the water level there is 2. So water level cannot exceed 2 because in that case it will overflow to the left. Now the how many units it holds there? It's this 2 minus its own height, which is 0 here. So therefore this slot, fifth slot, holds 2 units of water. This is in the same way you have to calculate this number of units for each slot, and the interesting thing here is this max L and max R both can be computed in one pass. I mean max L in one pass from left to right, and max R in another pass from right to left.
Yeah.
So I'll take one example and explain how it can be computed in max. Take the example of max L, which is the height of the highest bar to the left, how we can compute in one pass. So start from the leftmost slot.
Anyone has any questions for that?
No.
Okay.
Okay. So start from the leftmost position, and you maintain a current max. That will just be your max L. And now when you encounter index I, you have the max L, and just store it in array. And if the height of the current slot is higher than max L, you update max L. This, I mean, the computation of max cell is
But
exactly analogous from it.
But you need the max cell like for every element. For
Yes.
example, for element number 2, the max cell is going to be 1. But if you go to n minus 3, the max cell is going to be 3. So the max cell is not like it's per element, right?
Yes.
Correct.
So okay, so here for element number 2, max cell is 1 and max R is 3. Right. The minimum is 1, and you subtract it, the result becomes negative, so it is ignored.
So basically, the idea is that at I, if you want to find out the max, if you know the max of I minus 1 and I minus 2, then that's easy. So basically, when you scan through, you just have already computed all the max for all the elements before that. So you can keep computing the max for each of them and then store them in an array.
Yeah.
So yeah, basically you're caching the results. So the same thing you do from the right. Then you have two resulting arrays. So based on that, you can just say what's the minimum and then calculate what.
We actually don't need to do the third pass at all, right? In the second pass itself, we'll know the answer.
Yes, that is some optimization. You can do all the calculation in a single array.
Yeah, you could do that. Yes, sure. Yeah, but yeah, fundamentally it is still off in time, and since you're using an array as long as you are n, and your space grows as much as your input elements, basically it's O of n space. Yeah.
Arun? Hello?
Yeah?
I have a small query as to... Can I go ahead?
Yeah, sure.
So, max R is basically the tallest cell higher than the current cell. Is that the definition?
So max R is the tallest cell to the right of the current cell.
Okay. Why should we store the height of the maximum?
Yeah, because so if you want to see how I mean till what level the water it can hold, right? So if you see the max, if you took the example of index 5, so the max R is 3, but max L is 2. So the lower of the 2 is where the water stops, otherwise it will overflow, right? So basically you need max on both sides to see what are the limits, and then that is the height to which the water can go.
Right. Can we do the same exercise for the second cell number 2? 0, 1.
Yeah. Okay. So cell number 2, the max left is 0.
0. You mean the first cell? Right?
Yeah. For slot number 2, the max cell is 1. The first bar. And max R is 3.
So yeah. Okay. You are talking about this. Okay. So yes, max L is 1. Yes, and the max R would be 3.
Yes.
2.
Right.
So it's not the maximum.
Max R would be 2, right?
Yeah. Now you take the minimum of the 2 max.
Are we talking about the heights here?
Yes.
Yeah. No, max R is going to be 3, but because max L is going to be less than max R, so max R doesn't matter.
No, max L should... I thought max R should be 2. Not 3.
For which element?
So maximum to the right of 2 to end of the array is what, 3, right?
Okay.
Because in this case, it doesn't matter actually.
No, but yeah, let's say it matters.
Well, it doesn't matter, but I'm clarifying the way it's computed.
No, let's say the height of the first cell is 5, okay? The first cell is 5, okay? So max R would be the limiting factor, right? I mean, it would be the deciding. So you would not take 3 into account, right? You should take 2 into account, right? Am I making sense here, or?
No. Actually, what will happen in that case, if it is 5, it will still be 3 because the water will come up in the after 2 as well, right? Because it is the same scenario as for cell number 0, 1, 2, 3, 4.
I see. Okay.
So Pramod, I am not sure. So did you get your question clarified or what?
So
okay.
Pramod, see if the cell number 2 is 5, right?
Okay.
Now and the cell number 3, oh sorry, I'm counting index from 0. So if the cell is index 1 is 5, right? So the maximum water you can fill at index number 2 is 3 actually. Because it can go as up as the index number 2, 3, 4, 5, 6, 7. Because index number 7 is 3, so it will be able to fill up.
Yeah. So, but it's the height of that second cell is also 1, so it cannot be 3. It's only 2. So what
fill up
exactly?
to the left.
He is imagining a situation where the first cell has 5 height.
No, I'm thinking index as 1, right? If index is 1, index at 1 will be 0 water because it is the tallest one.
So what exactly is the question that you have, Pramod?
No, it's now becoming a doubt. But the question was like, how is max R and max L defined? I think from what I got is max L is the tallest cell on the left, and max R is the tallest cell on the right. Right?
That's correct, actually. Yeah.
But what I'm not able to understand.
Yeah.
Is, let's say the two cells. Yeah, I'll take the same example. Let's say the first cell is of height 2 instead of 1. Okay. And
first cell is 5, 2. Okay.
And the first cell is of height 2.
Okay. Okay.
And the second cell is height 0. Third cell is height 2.
Okay.
So now only that part of that vertical bar will be filled with water. Right?
Yes.
So if we store 3, then we are wrongly capturing the fact that we can store water all the way. Okay?
No, but max L is 2 and then max R is...
So that is why we are taking the minimum before computing the... Okay. So see, whichever is smaller is the limiting factor, like you said. And so that's why we are taking the min of those two, and that is the height of the water. And then we are adding the current, subtracting the current height of the current cell. And that will be the capacity.
Okay, then maybe I'm confused. Sorry about that. Yeah. Thanks.
Okay. Yeah. So yeah, let's move on to the next one. This is the last one.
Can I just sum up that? So once we find the max L and the max R, we take the minimum of those two and subtract the current height from that one. That, is it?
Yes.
Okay.
Any questions? Okay. Yeah, so let's move on to the next one. This is, you have 2 sorted arrays, and you need to find the median of the combined array. So what's the easy solution?
Easy one would possibly be just, go over both the arrays and you'll get the length of the arrays, right? So actually, instead of going over the arrays, you just simply, when the arrays are given, obviously the lengths are given. So forget about the smaller, so if you have say sizes 5 and 10, when you have 15 elements, that is an odd number. So I suppose the 7th element would be the median. So so the first one has 5 elements, so we directly start. Actually, it's something like the merge operation you do.
Exactly. So this is just the last step of the merge sort operation. you can just iterate until half of the elements, and then you
exactly.
can. Yeah. So that is.
We'll be there halfway through. Yeah.
Yeah, that's just O of n. That's the easy solution. Any ideas on the moderate one, O of log n?
So you basically try to eliminate number of cells, right? For example, if you start from the first array, and then you see the first index of, like, the first element of the first array, if it is less than the first element of the second array.
Yeah.
If it is, you keep on going.
Yeah, so
until you find.
That's the first solution that we just spoke about. So the merge operation of the merge sort, right?
Oh yeah. Log. The other thing you can do is that whichever element is larger, using the quick sort in the other array, you try to find out element which is just less than or larger than that element, right?
So it's already sorted.
Yeah, that's something. Using binary search, you can search the other array to see how many indexes you can skip.
And n by 2, right?
Yeah, n by 2.
So what will you search for?
So right now, like with merge sort, the problem is what we are doing is that we are going one by one until we find the next element that we want to pick from the first array.
Correct. So
now what I'm saying is that
so your insight is right that you have to eliminate half of the array every time you do something. Right. That's correct. That's what will give you the O of log n runtime. But yeah. So how would you do that?
Let me think about some example and then I can.
Sure.
So
anyone else?
Yeah, let's say you compare the middle elements of A and B.
Okay.
Right. And let's say that the middle element of A is less than the middle element of B.
Okay.
So in that case, you have already eliminated the half of A n by 2 elements, and those cannot be the median, right? For the larger array, because the larger array's median will be n plus 1 divided by 2.
Can you repeat that? So you find the two middle elements and then do what?
So you compare the two middle elements, and let's say the middle element of A is less than the middle element of B.
Okay.
So in which case, so that means that all the elements in the left-hand section of A are less than the middle element of B also by definition, right? Because they're sorted and the middle element. So the only part where you have to search now is the right part of A, and you still have the whole B array, right? So on the right part of A, you again compare the middle element with the middle element of B, and again, if they're not equal, let's say again the middle element of the right part of A is less than the middle element of B. You have eliminated that small the left part of that small array.
Yeah, so your general approach is correct, and I'm not sure if I caught on the specifics. So the middle of A is greater than B, or what?
So I'm to be honest, I don't have the complete solution. I'll write it down, but I'm kind of thinking that every time you're eliminating a certain number of elements, so the first time you eliminate n by 2, right, and then you have on one side you have an array of n by 2 compare it with n by n a full n array, right? As you keep eliminating elements based on comparison of the middle elements of the two arrays.
In fact, you can eliminate half of the array even in the second array. You need not compare n by 2 with n. You can cut down half arrays on both the arrays.
Actually, this will not work. Like if assuming I have two arrays, one array is 1 3 5 7 9.
Okay.
And another array is 1 2 3 4 5. Right. So
okay.
In the first array, the middle element is 5. In the second array, the middle element is 3.
Okay.
So by definition, and actually if you see, these are 5 by 5 arrays, right?
Yep.
So the median element is at 5. Okay. So if I eliminate the first 3 elements from the second array, means if I eliminate 1 2 3.
Okay.
Right. So the median in this scenario is 1 1 2 2 3 and 3. How will I reach to 3?
So 1 1 2 3 3 4.
So the first array is 1 3 5 7 9. Second array is 1 2 3 4 5.
So let's just take this example: 1 3 5 7 9 and 1 2 3 4 5, right?
So okay, let me change the example. The first array is 1 1 5 7 9.
Okay.
And the second array is 1 2 3 4 5.
Okay.
Now how would this algorithm run to get, because if we discard the first 3 elements of the second array, then we'll not get to the right median.
You discard the first 3 elements. Okay. 5. Let me see. 1 1
5 7 9.
1 1 5 7 9 and 1 2 3 4 5. So I'm just,
yes.
So first we'll do is we'll just merge it and see what's the exact median.
Yeah.
1 2 3 4 5 5 7 9. So it's 3 plus 4 by 2 is the median, right? 3.5 is the median.
No, median is 3.
So if you have an even number of elements, the median.
Okay, 3.5.
Yeah.
Okay.
So here it's 3 and 4. You have to get it 3 and 4. So that would be the answer, right?
Yes.
So the midpoint is 5 and 3, and if you discard the left half, so basically in the sorted array, 5 will be after 3, right?
Yeah.
So the median has to be somewhere in between these two elements. Basically the middle point of array A and middle point of array B, the median has to be somewhere in between. So if you see which one is,
but actually the median is not somewhere in between. The median is 3 and 4.
Sorry. So what I meant is after you've discarded that arrays. So okay, let me say this. So you've got.
So what you will discard if you talk in this array, like what will you discard in the first term?
Right. So no, I'm saying we will get the ordering. So once you have 2 midpoints, so 5 is greater than 3, right?
Yes.
So the median has to be somewhere below 5 and above 3.
Okay.
Right? So you have to hold on to the first 3 elements of the first array, last 3 elements of the last array, and then you do this again. So you now have 1 as the midpoint and 4 as the midpoint. Let me write this on Etherpad, I guess.
No, I get it. So 115 becomes the first array, and second array becomes 3 4 5.
Yeah.
And the total number of elements that we have discarded is 2 plus 2, 4.
Okay, in my example, I have a 5 here, and the sorted.
I think you have an extra 1.
No, it is right. 11579 and 12345.
He added 1 in the example he had. So yeah, so this becomes after you discard, it becomes 3, 4, 5.
And the first becomes.
So in the next.
No, the first becomes 579, right? No, sorry, 115. Okay.
Yeah. So. Yeah. So Mohammed, just I am writing it on either pad.
The median is 4, right? There are
actually you missed to add one more 1.
So here on line 19, we've written the whole array.
Yeah, you have to put one more 1.
Okay, I got it. Sorry.
Oh, there's 3 ones. Okay, yeah, correct. Yeah, so the median will be 3 and 4, and that will be 3.5. So basically, yeah, once you compare 5 and 3, you know that the median has to be after 3 and before 5. So you just maintain those subarrays, and then you do the same for the rest of the array.
So 1 and 4, right? So now you get 1 on 4, and if you put the same logic, what you're saying is that the median is between 4, 5 and 1.
So the next time you do this, it will be like this. So when you get to 2 elements on each of the side, then it's actually trivial to see which one is the lower one, and then you can decide. So you have to take the max of the first element, which is 3, and then min of the second element, which is second column, which is basically 4, and then
no, but like
wouldn't B be 4, 5?
What's that?
Wouldn't B be 4, 5?
3, 4 is right, because whichever is a larger element, we take left of it, everything, including that. If you see from 11579 and 12345, we took 115 and 345.
Yeah. Okay, yeah. Sorry.
Yeah, I didn't understand, like between 1, 1 and 3, 4, why would you put 3 plus 4 divided by 2?
Right. So here you have, so again, if you go back to, if you again merge this, 1 and then 3 and then, sorry, yeah, 1, 3.
No, assuming if A and B, like 1, 1, 3, 4 are the actual array, you will not find an answer, right? Because the answer now between 1, 1, 3, 4 is 3.5. No, it's 2. Right?
So you're saying if 115 and 345 was the array, then you would not find the answer?
No, I'm just saying if assuming there are 2 arrays, 1, 1 and 3, 4. What's the median?
1, 1 and 3, 4?
Yeah.
It's not 1, 1, it is 1, 5 and 3, 4.
Yes, it's 1, 5 and 3, 4.
Ah, okay, sorry.
Yeah, so basically once you hit 2 elements, it's a little easier to do it by hand, so you can just now conclude. So the A of 0 and B of 0, you can find the max of that, and then you can find the min of the second column, and then because it's not equal, so if it's an even, if it's an odd number thing, this will probably be equal, and then you can just exit with that, because there'll be only one element.
Okay.
I didn't get this last part. So for A and B, we'll find the max for each I because we have just like two integers, and then whatever the max is, we will take that, right?
Let me write that down. So it's max of AF0 and BF0 plus min of
min of, okay.
Yeah, AF1 and BF1. So this happens if there is no, because there are what's that, even number of elements, and you have two elements that you have to.
And what will be the formula if there are odd elements?
So odd elements you can just test for equality. Usually so when you're getting the midpoint of the two arrays, there will be a point in which you will just see that the two midpoints are equal. So then you can just exit that method. That's the limit.
So if it is an odd point, again we can reiterate it, right?
Like if it is 111579, right? Assuming the first array is 111579.
Okay. So yeah.
Oh, sorry, I lost the.
Yeah.
Actually, I think instead of coming up with formulas for the trivial cases, I don't think anybody would mind if we create a array of 3 or 4 size and merge it. Actually, it won't take any time.
What's that?
Instead of actually coming up with formulas like max and min, so there will be different formulas when we end up with 4 elements, when we end up with 3 elements.
No. So this is the base case I'm just talking about. So the base case is if there are odd number of elements, then you would do the thing that's on line 30. And if there are even elements. If there are odd elements, usually the midpoint of the first array is equal to the midpoint of the second array. So you can return at that. So you can just return for AF M1 or something. So when it's not equal, when it's odd, you have two elements in the middle. So you would have to decide whichever way you did. So you have to do something like this.
Yeah. How do we solve if both the array sizes are different?
What's that?
The both array sizes are different, like.
Yeah, so that case we have not yet done. This is just same size. That is a little more complicated, I guess. Any questions on this median of two arrays?
Actually, if I want to summarize this solution, so the one you said earlier that you can discard from both the arrays, so that I think I can help. Probably I have a solution. I'm not sure whether it's the same which you discussed, but I think I can explain in just purely theoretical terms.
Okay.
So
let me just say this before we start. Okay. So if you see on line 16 and 17, and then 23, 24, 26, 27, we have been successively cutting down our array by half. Right? So that is why it's log n, basically. That is how it becomes log n. Yeah, go ahead.
Yeah, okay.
Before that, can I just interrupt? Arun, after this question, are you going to take any other questions or something?
No, I think.
Oh, okay. Then thank you. Then I will leave. Thank you very much.
Okay.
Yeah. So sorry, I lost track of this individual example with numbers. To solve the question completely theoretically without going into the details of whether of the specific cases of even numbers, odd numbers, and let's take the general case, like where we want to find the kth number, because when in the merged array, because when you are going to discarding numbers in the next iteration, we we will not be looking for the median. We'll be looking for the, say, n by 2 minus the number of elements discarded in the previous iteration. So let's take two arbitrary positions, say L1 and L2, in the first array and second array respectively, which are unknown. Now we only know L1 plus L2 equals to K.
Just a minute. Someone here has asked, can you just repeat how is it log n? So if you see the input we have is A and B, which is if you consider that as n combined, then every time, every iteration, like every recursive call that we do, the array reduces by half of them. We are discarding half of the elements, and then there's a base case where if the midpoints are equal, you do one thing, and if the midpoints are like 4 elements, then you do some simple logic and you basically get the answer. So this is very much like binary search, where you are halving the search space with every computation. I mean, with every call. So that's why it's log n. Okay. Yeah. Go ahead. Sorry about that.
Oh, okay. So let's take two indices in the two array. So in array A, call it L1, and in array B, call it L2. So both L1 and L2 are unknown. These are the actual indices which are unknown. We only know that L1 plus L2 equals to K. Now we need to find L1 and L2. So we do not know L1 and L2, so we make a guess, blind guess. Just divide K into two approximately equal halves, say M1 and M2. These are the indices into array A and array B respectively. So again, M1 plus M2 equals to K. So we have two unknowns, L1, L2, and two known numbers, M1 and M2. L1, L2 equals to K, and M1 plus M2 also equal to K. So now the observation is, if in array
what
A,
is L1 and L2? Can you just repeat? Sorry.
L1 and L2 are the actual indices or positions of the number I mean in the merged version, which gave you the I think the kth element.
Okay, so in the final array, you're saying their two indices are L1 and L2.
Yes.
Okay.
Yes. So we just need to find L1 and L2. Similar, we make a guess for L1 and L2, which are the M1 and M2. These are known numbers, and they follow the same constraint that M1 plus M2 must be equal to K. Now the observation is, in array A, if L1 is less than M1, then in array B, L2 must be greater than M2, because L1 plus L2 equals to M1 plus M2.
So if L1 is lesser than M1, you said?
Yes. For the L2 and M2, it will be opposite. If L1 is less than M1, then L2 must be greater than M2, and vice versa. If L1 is greater than M1, then L2 must be less than M2.
Okay. So
now depending on now after checking this, which is the case, we discard half, approximately half, or maybe some portion from both of the arrays.
Right.
Say we take the example, L1 is less than M1 and L2 is greater than M2. So we are on.
Sorry. I thought yeah.
Hello. In array A, we are only interested in the position L1, and L1 is actually less than M1, so we don't. We can discard the elements greater than M1 in array
A. Right.
Yeah, and since we are discarding elements, beyond L1, those which are not going to affect the value of K in the next iteration.
Right.
Because only the elements we discard from the beginning is going to affect the value of k in the next iteration.
So that is exactly the logic behind this solution. Yes.
Yeah. Similarly, in array B, we discard the elements less than M2, and we remember how many elements were discarded and subtract that from the value of k in the next iteration.
I had a question. So, like in the example which you solved earlier, like the A and B, we took the input earlier. So we have taken odd number of elements. So in each of our iteration, we have had only one median. So I mean, we haven't seen a situation where we need to actually, take the average in not the final step, but in one of the earlier steps. So if we can make, if we can add, if we can possibly take one of the arrays to be even, I want to see what elements we discard. If we have like, an average median.
Actually, this is a case where we have to do average. So if you see 3 and 4 are the two elements and our median is 3.5. So 3 and 4 are the middle two elements. So that's what kind of we are doing at line 30.
Okay. No, I mean, after that, see, suppose this was an interim array. So 3 and 4, 3.5, we got to be the median. So which half will you pick? Will you pick 3, 4 included in the half of the array, or will you leave out 4?
Which half of the array?
Now suppose this was a given array, like this line number 19 was a given array.
Okay.
Okay, and suppose we had another array, say 3, 4, 5. Okay, any array. So the first step would be, to find the medians of both the arrays and ignore half the array based on that, right?
Sorry, just a minute. Okay. Yeah, go ahead. Sorry about that. Can you just repeat what you said?
Okay, so now let us assume that on line number 19, the array which is written, that is array A.
Okay.
Okay, and suppose we had another array B, 3, 4, 5.
Yeah.
Okay, so now what we generally do is we find the individual medians of both the arrays, and then we ignore half of one of the arrays, right? One half from both the arrays. So that way, in the given array, my median is in line number 19, array A, my median is 3.5, and in array B, my median is 4, because the array is 3, 4, 5. Okay. So now I want to know what half of the array will I ignore from the array on line number 19. So my median is 3.
So the first thing is we will not have 3.5 if you are doing with two arrays like that. So probably you would have 3 or 4, and then since both are sorted, and then you can see which is greater between the median, say 4 and 3. So since 4 is greater than 3, I will assume, so it's not assume, but basically the median is can be computed if you just have the elements from 3 to the end of the array in array A, and from beginning of the array to 4 in array B. That is all that you need to compute the median, right?
Okay, but I actually, I know we are out of time and stuff, but I actually found a case where... Yeah, no, I found a case where, if we pick, like for instance here we got we got an average median, right? Which is why we picked 3 and 4 in half of the array. So if we pick both the elements, there are cases where we will get the wrong answer.
We pick both the elements?
Yeah, we get the wrong answer.
Okay, can you give me an example right on the Etherpad?
Okay, everybody can edit this. I don't know.
Yeah, you can.
Okay. So let's say I had 1, 1, and 5, and I have 1, 2, 3, 4, 5, 6. Okay, so now my first step would be, median in my first array is 1, and my second array is 3 and 4, right? So I'm going to pick 1, 2, 3, and 4. Sorry, first I will pick 1 and 5.
You will pick 1 and 5.
And the other array became 1, 2, 3, 4. Now, after this, so 1 and 5 will remain 1 and 5. And now I have 4 elements, right? So I take 2 and 3. So now I get, now I have 4 elements. So if I were to merge this.
How did you take 2 and 3? So basically you have to again compare the midpoints.
Sorry, I should take 1, 2, and 3. Right.
You're taking 1, 2, and 3. Okay.
Yeah. So now.
Okay. And
now
then
I have. Now then after this I get 1 and 5 and only 2. So in this case, now since I have 3 elements only, 2 is my answer.
Yeah, so this actually, whatever I wrote, it's not for, I think it's not for different sized arrays. Solution might be a little different.
Yeah, but I mean, if I were to directly merge this, like for instance, if I was to merge it, I would have 1, 1, 1, 2, 3, 4, 5, 5, and 6. So clearly my median is 3.
It's 9 and then your median is 3. That's correct.
Yeah.
Yes.
But I'm arriving at 2.
Yeah, so basically this algorithm, whatever you use, so whatever my question, right, this question is actually for same size arrays. So first thing is these arrays are different size, and then so maybe there is some modification you need to do for the logic. So if you have 1, 2, 3, then what do you do? You compare the midpoint of this and this. I want 2. Yeah, and that won't work. So if it's of different size, can you think of any solution if you have different size arrays?
No, if I were to actually, when we have a situation where we have like even elements, we are picking 2 elements, right? So instead of that, if we ignore one of them, I think we would arrive, in this case, we would arrive at an answer. But I don't know if we could generalize it.
What is that? So
let me
wait.
This
no, let me. I'm just running through this solution in my mind. So you took the upper, the upper interval. You took 4 as the pivot, like, and then you kept the rest, and then here again you did that. Again you took 3 here, and then you put the rest. So now you have to take 5 since you're taking the upper pivot, and then if you take 5 and you would have to basically, this will get eliminated, and then you will have just 2 and 3. Yeah, so what you have now, Yeah, so this approach probably doesn't work for different number of elements. I have to see what's the right solution for this. Any ideas?
In these last two steps, we are not eliminating anything from first array, right? We are simply keep going with 1 and 5.
Yeah. So the thing is, so he used so when you do n by 2, he's using the ceiling function to get to the index. So here he has 1 5 and 1 2 3 4, right? So if you have it, there are 4 elements, you'll get 2, but he's taking until 3. So his midpoint is 3. So he's keeping 3 elements. So if you do the same thing for this one, then you would have to compare 5 with 2. So if you compare 5 with 2 on line 41 and 42, you would actually have to discard, I guess, the whole of line 41. You would just be left with everything to the right of 42. But that would be just 1 array and 2 and 3. So yeah, how do you decide which is the median? I'm not sure. So
if it is 5 and 2, then we need to discard 1, right, from A?
If it is what?
No, if it is pivot is 5 and 2 from A and B, so we got to discard 1 from.
Yeah, so that's what I'm saying. So the way you're selecting the pivot, so here he's selecting, so there are, on line 36 there are 6 elements, and then if you do 6 by 2, that is 3, right? So he's taking the ceiling, that's the 4th, he's taking the 4th element. So the same thing, so you have to apply the same ceiling function to the other array. So once you have 2 elements and you do by 2, so it's 1. So it would have to be 5 here, and it would have to be 4 by 2 2. So that's 3. So you would have to compare 5 and 3 on line 38 and 39, I think.
Okay. When we are comparing 34 and 36, the pivot is 1 and 4, right?
Pivot is 1 and 4. Yes, correct.
So if it is the case, then we got to discard 1 5, isn't it? Okay.
You have to discard.
We got to discard the right side one from A.
So 1 and 4. So since 1 is lesser than 4, the median will be to the right of 1 and left of 4, right?
Yeah, no, Arun, in the case which you were mentioning, where we take the ceiling in both and we are arriving at 3, that is not the case, right? So even if suppose I was taking ceiling for 2, so when I am on step 38, 39, so you're saying that we take 5 and compare it with 3, right? So my in the next step, I will, if that were the case, in my next step, I would come to 5 and 1 2 3, 1 2 3, and then in my next step after that, I would come to 5 and 2.
5 and 3 4, right? So whichever the element is lesser, everything to the right should be taken, because, and then whichever is greater, everything to the left should be taken, because
right.
Between those two things, your median lies.
Okay, 5. So that way you said 5 and 3 4.
Can we try the exercise again with the same example?
Yeah. So this is 1 3 4 and 5. So this is 3.5, right? Again.
Yeah. So let me.
Okay, there is only 5 here. Okay, only 5. Okay, I got it. but I don't know if we can generalize this.
Yeah, so yeah, I'm not sure about the different elements problem either. I have to see and check whether all the test cases work or not.
Yeah, so, this answer is 4. This is not even 3, so this is wrong.
No, I think we have a wrong answer in row number 38 and 39. I'm expecting there 1 1 instead of 1 5.
Yeah, so the merged array will be like this, and 3. Yeah, so 3 is the median, right? Okay. So right. On 38, what are we doing? So when you compare 1 and 4, right? You're comparing 1 and 4, are you? Yeah. Okay.
Yes. Yes.
So then you have to take everything to the right of 1 and left of 4. Yeah. Correct, right?
Yeah.
Because the median will be somewhere between 1 and 4. You have to basically take the whole. So and then again.
No, if it is we need to discard the left of max, right?
You need to discard the left of max. So the thing is.
No, the right of max.
Yeah.
Oh, is it?
Because your median will be between your min and max, right? So you want the portion in between your min and max. Does that make sense?
Yeah.
So somewhere in between you have to find. So you basically have to discard the others. So same thing, and then yeah, 38 and 39 seems to be okay. But yeah, 5 and 4. Yeah, I guess, yeah, I'll get back to you on this one. I'm not sure what's the solution for different number of elements. But yeah, I'll be sure to post it. We have 1, 5, 2, 3 finally. What's that?
Yeah, Mohammed, that was the answer. I mean, that if we follow the ceiling function, we arrived at 2.
Okay, using the line 30. Yeah, so the line 30, I guess you will have to have 2 elements in each of the array. So here there's 2 elements in one and 4 in the other. So yeah, that's what I said. So for different sized array A and B, if you see on 35 and 36, the size of the arrays are different. So maybe some change needs to be done, which I'm not sure about right now. So any other questions which is not related to this different size of the array? Okay, Mohammed says something here. With different sized arrays, we get 1, 5 and 2, 3. Okay. Can you write that on either pad, Mohammed? What are you trying to say? Can you write on line 54?
No, Mohammed. Actually, we get 1, 5 and 1, 2, 3. And then finally we get 1, 5 and 2.
Okay. Yeah, I guess. Yeah. I think yeah. If anyone has any questions, we can stay, or else I think we can end this. Any questions? Going once, twice. Okay. Okay, guys. Thanks a lot for bearing with me. Yeah. So probably next week, Vivek will be back. Hope to see you all. Yeah. Bye.
Thank you.
Bye. Thank you, Arun.